Hi, we're going to start today's class here. The first one here you can see the topic we're going to talk about is media here. That you can thinking about the cable, the hardware, talking about LAN. LAN, you want to share some resource, like in a classroom, you have 25 computer, you only have one printer, so you are going to share those printer. We are not talking about Wi-Fi, we are talking about wireless cable. So you're going to have those kind of cables. So which kind of cable you have typically in a classroom, that's going to be this kind of cable here. This kind of cable here, we can call it STP, UTP, shredded, unshredded, different type, twisted pair cable here. Now, in a classroom setup here, you use your computer via this cable connecting to a switch and coming back via another cable going to the printer. So that's how you print here. So this is the we want to use here. Since 1920, AT&T, Bell Lab, they create phone. We are using the same cable here. So if you don't trust me, you go back to your apartment, to your house, you cut off your phone cable. You're going to see the same stuff here, 1, 2, 3, 4, like 8 wiring in 4 pairs here. But don't do it here. You're going to ruin your phone line here. Just trust me. And in there, they have that kind of stuff here. You can thinking about one is like sending out your voice. One is coming back for other people's voice here. And one is to set up to sync, to make it in sync here. That's basically the idea you need, those pair of cables here. Now the question come back here is why you want to twist it here. See here, you twist it here, twist it here. Why don't you untwist it? Well, so what's the point? That's physics here, because if you have two current here, they are running all the same way, they are going to generate a magnetic field. Magnetic field here means noise here. If you don't do that, twist it here, say no twisted here, so you have two, no twisted here, they are going to have a current running from here to there, there to there. You are going to generate magnetic field. The magnetic field means noise here. You don't want noise here, so what are you going to do? The phone company since 1920, that was 100 years ago, we use this technology here. We twist it here, so you have twisted pair, twisted pair. They're trying to tell you once STP, they contain a metal field here. This metal, this don't have any metal here. So STP, UTP here, two different type. One is much less noise, one is more noise here. Say if we use STP here, so that's what we use. That's STP. This is the phone cable here, from left to right here, left to right here, for type here. Say twisted pair. Yep, you just say twisted pair. That's fine. Shredded or unshredded here is not important. So you say twisted pair. That's for your home phone since 1920, still there. And that in our classroom here, we have a LAN. That's your LAN cable. How about that? LAN cable, phone cable, that's your cable called twisted pair here. Another type of media here is this one here. You see this one look like what? This look like fiber. Different term are used, say optical fiber, fiber optical, same media here. You see them? They have one metal here, and that's the fiber here. The difference between this one here, twisted pair, and the fiber here is fiber can carry much higher bandwidth here. You can think like backbone. The main cable are all going to be fiber here. And that's from my computer to a switch. That's this one is good enough. If you use this one, that's overkill. Overkill means you don't need that kind of speed here. You have waste of money. Fiber is much more expensive here and difficult to handle here. Verizon used to have we call files, FIOS. FIOS. That's files here. That's Verizon. Verizon sold that portion of business to Frontier. Right now you have Frontier Files, FIOS. If you live in a very, very remote area, you call Frontier they're not going to come here and install a fiber for you. It's going to be cost too much to do that. But if you live in an area, there are many people, yes, they will. They come here to install a fiber for you. Then your bandwidth will be much more higher here. For instance, here with this twisted pair, if your bandwidth is like 2 megabits per second, I'm talking about internet speed, or 10 megabits per second, that's fine. But with Fios here, you can have 50 megabits per second, 100 megabits per second, comparing to or 10 to 50, 100, or even more. This is much higher. You say, no, I just want to use with my twisted pair. Please give me 100 megabits per second. Cannot. They cannot carry that kind of stuff here. Well, an analogy here is this one can run not that fast here. This one can run very fast here. So, and that's optical. Oh, this is a coaxial cable here and optical fibers here. So, oh, okay. So I messed it up here. So that's your cable TV cable, and this is your fiber, so on. So that's not that fast here. The fast here is much more faster here. So the fiber stuff. Fios here. Cable TV, cable here. If you have a cable modem, whoa, that's the cable you are using. If you have Fios, that's the cable you are using. If you have like DSL, digital subscriber line, that's this one you are using. Typically, there are at least 3 ways to connect into internet. Depends on the technology here. DSL, digital subscriber line, twisted pair, and cable TV cable modem. That's this cable TV cable, and fiber here, Fios, F-I-O-S. That's 3 different types we are using here. Yeah, so this one here, you see Cat 6 here. This cat is not your house cat here, got nothing to do with that. It's a category 6 here. Typically you use Cat 5 here. So you're going to hear the term Cat 5, Cat 5, Cat 5, or another term Cat 6 here. Cat 6 is much higher if your existing network here, they use Cat 5, or if your network is not going to be that fast here, then Cat 5 is good enough here. Otherwise, you may use Cat 6 here. Again, overkill, waste of money is not a good idea. So this one, either Cat 5, most widely used, or if you want to using the newer category 6 here, Cat 6 here. So now you hear the term Cat 5, Cat 5. What's Cat 5? Cat 5 is this cable here. In your classroom here, you have a Cat LAN, and Cat 5 is a cable connecting your computer to the printer. Cat 5, CAT5. Coaxial cable, we're talking about cable TV cable here, can be used to send you the cable TV programs here. At the same time, they can let you use it for internet access here. And fiber optical cable here. This is the fiber optical cables here. So we're fine. Are we using this one here at home here, in your office here? Yes, I think you are. Thinking about previously, we are using is wild here. This is LAN, L-A-N, local area network. We are talking about Ethernet, E-T-H-E-R-N-E-T, E-T-H-E-R-N-E-T, Ethernet, or AO2, AO2.3 here, AO2, it's easy to remember, 80 here, AO, 80 here means 1980, the year 1980, AO2, study group February, AO2, 1980, February, .3 here, .3 here, that means study group number 3. In 1980, February, so AO2, .3, study group 3, was assigned to set up the standard for Ethernet. That's why you say Ethernet, AO2.3, that's the standard. Ethernet is the technology here. LAN, we're talking about LAN. LAN used to be, we have other technology like token ring and other technology here, but today we only have Ethernet. Therefore, if you see people say LAN, people say Ethernet, people say AO2.3, they're talking about the same stuff here. So that's your stuff. That's wild here. Cable is wild here. And comparing to that here, we have wireless. Wireless is microwave. You guys know that microwave. That's the term we use for microwave here. That's wireless here. A wireless access point here. Yeah, that's for instance your computer is here. That's your computer here. Wirelessly via microwave connecting to an access point, then connect to a we call router, and connect to your router here, connect to a internet, a cloud here. The wireless network here, and that's talking about microwave gigahertz. That's the vibration here. And talking to create LAN here. Now you're talking about not the wild like a previous page. We're talking about wild AO2.3 Ethernet. You're talking about wireless here. Wireless here, you need to like that's AO2.11. Remember your AO2? 1980 February. Study group 3 set up the wild Ethernet. 11, they were assigned to come up with wireless technology, the standard here. So this is the standard here, spec. Then they call AO2.11, study group 11, or Wi-Fi. So Wi-Fi AO2.11. Wi-Fi technology here, the standard or the spec is called AO2.11. So what is that? That's IETF. IETF, Internet Engineering Task Force. I'll show it to you in the next page. What is IETF? You need to know this organization. A organization set up the standard here in 1980 February. They have formed some people, study group 11 to come up with Wi-Fi. Then they call their standard called AO2.11. That's equal to Wi-Fi. And with Wi-Fi, you need to have a wireless access point here to connect you here. So your computer connect to WAP, WAP connect to router, router go to internet here. There's a wireless adapter here. So, okay. Then that's wireless USB adapter here. That's fine here. We all know USB. USB have 1.0, 2.0, 3.0, 3 different versions. So in this case, if you bring your USB, if this USB is 1.0, and you bring to school, and if the school computer 3.0, they cannot read it. It may happen. And at home, your computer can read it. School computer cannot read it. It can happen here. Different standard here. So depends. Some compatible, some are not compatible. So I always have students say that, whoa, I can see it from my home computer, but right now I cannot see it in the classroom computer. What's going on? I see. That's a different standard here. So that's your USB here. Before USB, we have a floppy disk. I don't know how many of you still remember the floppy disk here. Floppy disk, it's kind of limited space here. And USB, that's very big space. You can install a lot of stuff, very little tiny about floppy. Not only like that, it's the I/O speed. Meaning, if you put this one here to your computer, you're trying to find something here, you find it right away. That's in I/O. This one have input to computer, computer have output to USB. You want to save something to your USB, that's input output here. But using a good old floppy disk, that was like 20 years ago's technology here. And using the floppy disk, the I/O speed is very, very slow here. You in your floppy disk here, you have one file here, two file here. You want to see that file here, you're going to hear the noise like maybe after 5 seconds or 10 seconds. Then you can see the file. This one less than 1 second. You see, that doesn't seem like a big deal between 1 second and 10 seconds. It is. It is. You don't want to wait on the 10 seconds here. So that's the reason floppy disk, we don't use the floppy disk anymore. We all have USB. And this is Wi-Fi here. Wi-Fi, this guy tell you like 100 to 200 feet. So another one, this is kind of a long distance here, belong here. They also have a short distance called Bluetooth. Bluetooth here. That was created mainly by Ericsson. When the time I worked for Ericsson, some other people, not me, they created this technology called Bluetooth technology here. So Bluetooth is like about 10 feet, 20 feet here, 10 to 20 feet here, very, very short distance wireless technology here. And it's Wi-Fi. So one is created by Ericsson, one is created by a standard body, IETF. So they are different here. Back to Ericsson, I didn't work on the Bluetooth. I work on wireless just mobile phone technology from 1.0. Okay, we call 1G, 1.5G, 2G, 3G, 4G. Right now it's 5G already here. So that's the stuff here. And AO2.11, the same idea. Take a look here. 1980 February, we form a study group called 11G, 11N, 11AC, 11AX. Then they all work on different speed here. Like 11G, they work up to 54 megabits per second here. This one, 11N, up to 600 megabits per second. Say, imagine you were assigned to work on to come up with Wi-Fi speed this big, and some people are assigned to be much more aggressive bandwidth here, or we call speed. And this one AC here, 1 gigabit, so 1,000 here. So you have about 54. Some of your friends have 600 here. Some of your friends were assigned for 1,000 megabits per second. So not a fast, very fast here. That was the different stuff here. So we have G, we have N, we have AC. Actually, we have A. So AO2.11A. We have AO2.11B. So, and that they have a G stuff here. You don't want to think like if you have AO2.11B and AO2.11A, so A is like version 1, so B is version 2, .C that's version 3. Not really here. It's not really like that here. Anyway, it's G is for this one here, and N is for this one. You say, hey, after G must be H, before N must be M. Not necessary here. No, that's just when they assign here. They want to do this kind of assignment here. There's nothing you can do, because if you are based on that kind of thinking here, you say, hey, this is the A here, so must be slower, G faster, N much more faster here. That's not the case here. You cannot try to interpret that way here. So basically, we're talking about AO2.11 G here. That's your Wi-Fi speed here. Say you can say that, whoa, okay, then a new network, they may want to have this one here. It's not like this Wi-Fi here can be shared by different computer here. So it's not like you're going to have 154 megabits per second, maybe shared by some people. If 10 people share, everybody have like 5 megabits per second here. That can be shared as Wi-Fi. There are many cities covering up entirely with Wi-Fi. So the city have Wi-Fi coverage here, and they can serve, say, 1,000 people to use at the same time. Then they have a very fast speed here. You go there, your speed may be 2, so something like that here. Say if this is higher than that, so you, for a city covering up with Wi-Fi, you need this one here, more than 1,000. Say 1,000, if you have 1,000 people use it here, everyone have 1 megabits per second. That's not good enough. That's not good enough here. So then that's because you need to have 1.5 megabits per second for videos. So 1 megabit per second will not be good enough. So you can do simple calculations, say that, hey, this is a small town here, been covering up by Wi-Fi with this kind of speed, 1,000 megabits per second here. Right now, they have 200 people use at the same time, so everybody have 5 megabits per second. That's pretty fast. That's good enough. Again, you don't need to have 54 megabits per second. You need to have 1.5 megabits per second. So that's the idea. Okay. The packet here is when you send out we call packets here, is like you connecting to internet here. You want to see the website here. The website here, they send back to your computer. You don't know. This is transparent to you. Your computer have software and hardware to handle that, and that's maybe in more than one packet here. So they have, let me see, they show you TCP/IP. Yeah, that's most important stuff here for internet here. Say, give you one example here. You type in the school tccd.edu website. You want to see the website here. How can you see it? Your computer, they have a browser here. Say you using IE, you using the Google Chrome, you using the Firefox. That's software. So we'll use the Chrome here. You click on Chrome here, you type in tccd.edu. You want to see the school website. So you did. You can see it here. How can you see it? Because once you send out, the browser send out this request, try to find the tccd.edu, they translate to IP address. They have a mapping here. You don't need to remember IP address. Maybe like 10.10.100.1. No, you don't need to remember. They have a mapping. Your software will do that for you. And once they found the IP address, they try to go to the IP address here, and the IP address is going to copy the website and send back to you. If you have a fancy website here, they cannot send back all in one shot here. They have to send it to you, your computer, 3 times. So the portion 1, portion 2, and portion 3. And each portion will call packets. That's called packets. And that's packets sending to you. Packets here need to have a header here and payload here. Header here, that's your IP address, your computer IP address. Once your computer receives that, will know. Computer say, oh, yeah, that's for me. And then that payload here, that's the content. Say 1/3 of the content of a school website here. And that's your header and payload here. So in this case, if you need to receive 3 packets in order to show you a school website, they're going to have 3 packets here. Packet number 1, number 2, number 3. Number 1 have a header, payload. Number 2 have a header, payload, header, payload. And the header always going to show the sending IP address, that's the school, and school computer, and receiving IP address, that's your computer, that's header information. So this one here, I mean, who sent it to who? Yeah, in the internet world here, that's called IP address here. And payload, that's the content here. Now we come back to here to see that what's a TCP IP. We talk about IP, remember? That's your address. The school have IP address. Your computer have IP address when connecting to internet. That's IP. So IP is in here. School IP, your IP, that's in here. And what's TCP? In addition to IP address, you also have a TCP. So what's TCP here? TCP, in this case here, we have 3 portions here. Based on this we call transaction here. In one transaction, we have 3 packets. So you're going to receive the first one, going to say 1 of 3. The second one here, going to say 2 of 3. The second packet here, going to say 3 of 3. That's 1 of 3, 2 of 3, 3 of 3. It's your TCP. Yep, you got it. You need not only TCP, but also IP. You need both. Now, next time here, if you receive someone to send you an UPS sends you a packet. Okay, you take a look for that packet. They're going to show you a UPS from UPS here and to your home address or apartment address. That address is IP. Then you ask, where is my TCP? You're going to see your TCP, that's for sure. If they are sending you are buying something here, they pack it into two boxes here. So for the first box here, you're going to say 1 of 2. The second box here, you're going to say 2 of 2. That's your TCP. If you buy something and they send out via UPS, they only have 1 box, what are they going to do? They still use TCP. The TCP is going to say 1 of 1. Then you search no more. Hey, that's it. So that's P, TCP IP. We need both to make things work here. So IP is an address, pretty much like your phone number, like your address here, your home address here. And TCP is a number of transaction here. More than 1, you're going to have 1 out of something. Only 1, you're going to have 1 out of 1 here. In this case, your computer received 1 of 1, your computer browser is happy, show it to you. In case your computer browser receive 1 out of 1, say now 1 out of 3, 3 out of 3, your browser will not going to show you because you are missing 2 out of 3. Your browser will send back to school server here, school ask where is my 2 of 3. Your server will resend. Then your computer will say, hey, now I have 1 out of 3, 2 out of 3, 3 out of 3. I have all I need. Then your browser will try to show you the screen here, the website here. So, we come back here with the P. So what is the P? P is the protocols. Protocol here. We use a protocol, and this protocol means different. So in internet world here, if you see something P, you may assume most likely, yeah, that's talking about protocol. Protocol is a rule here, protocol here, like IP protocol. So what is IP protocol? Internet protocol, meaning for internet address here. They have a format like 10.10.100.1, 4 portion here, separated by dot. And TCP like 1 out of 3, 2 out of 3, 3 out of 3. That's the figure of speech. In reality, TCP will not have 1 out of 3, 2 out of 3, 3 out of 3. They're going to have a very, very long number like 532.1.1.1.1 and 532.1.1.1.2.2, 532.1.1.1.2.3. That's 3. Then they are going to have a counter, say like counter 1, counter 2, counter 3, and they're going to say and, something like that. That's your TCP. Very, very big numbers here. But the idea is the same here. That's your protocol here. Internet is based on TCP/IP protocol. That's why you hear a lot of TCP/IP. Do you think you can handle what's TCP/IP? How about let's try to find the TCP/IP standard. As I mentioned to you, 1969, thinking about 1970 earlier. That was like 50 years ago. Department of Defense created Internet, and based on the TCP/IP, Internet is like moving company. They move from point A to point B, point B to point A, and this moving, I have 10 stuff I want to move to you. So that 10 stuff is TCP. Moving from point A, point B, that's IP. So they need to have these protocols in order to work, meaning the sending side, receiving side, they follow the same format here. You're marking 1 out of 3. And the receiving side know what's that. So that's your TCP/IP. Let's try to find the TCP/IP standard. Since 1969, created after about 10 years, the government gave this internet technology to a business like IBM, and the way they gave it to is publish those standards under IETF. Under IETF, then you have that. Then you know what's TCP, what's IP. Okay. So we come here, we try to find TCP/IP. Let's see here, you can try to find TCP/IP, you Google here. So you want to Google here, say TCP/IP. So try to find TCP first, just type in TCP. Then what else you want to type? You want to type RFC. Now, what is RFC? RFC here is request for comment here. It's a standard, spec number. Standard number, something here. TCP, you see TCP, they have different, the RFC here, RFC here. This one is original RFC, 793, TCP, RFC 793 here. Or if you don't know, you can search like 1122, they're going to tell you, original one is 793. It's not like we have newer ones, so see, yeah, I'm going to go with this guy here, 2018. Those are obsolete, they are not obsolete. This is the original one here. The main idea is in here, and they add some more stuff, add some new stuff, add some extra new stuff, extra new stuff here. So you in the industry, you want to understand everything here, but the basic idea is in here, still used. So you see the small number here, 793 here. That's your RFC. That's like stuff. I Google TCP standard number here. I actually remember because I was working in industry for 15 years. I remember I use it a lot here. But for you, you may not know, so you Google. You Google, say, TCP standard number, spec number. What's the number? You say, okay, maybe 793. So you try to remember 793. Then we need to go to where? We need to go to IETF, IETF.org. IETF. This is one term you have to memorize. Internet Engineering Task Force here. Internet Engineering Task Force. IETF.org. That's your internet standard. They're all there. So once we have IETF.org, we enter. We come to the site here. Then we want to find internet standard. Then we want to see RFC, standard number RFCs. So come here, RFC, then you're going down here. You say RFC search page, search for RFC. Remember, we're trying to find TCP, so they tell you RFC number here. We just saw it say, say 791. Then let's try to search. 791 here, they have RFC 791 here, 791 here, September 1980 here, obsolete internet standard. See here, right hand side, internet standard here. Yeah, internet standard. So that's your IP standard, internet standard here, RFC here. Yeah, okay, that's IP, internet protocol. See here, the title here. We're looking for TCP IP, we're looking for IP, that's internet protocol. That's the IP. And this guy is 1981. They gave to company like IBM. And obsolete, 760. So 760 is not used. You don't want to check. But this one's still used. And updated here, some new stuff, 1349, 2474, 6864. So what do you want to know? You need to learn 791. Working in industry, you also need to learn this one, and this one. This one obsolete, you don't care. Okay, so we got 791 here, no problem. I think we found it here. That's your TCP, that's your IP standard here. Okay, so that's your IP standard here, internet protocol. Then we search. Let me see, now we found it here. So we say one search, we'll click on this one here. 791 here. Whoa, standard RFC 791 internet protocol, TCP IP, this is your IP, September 1981. It's very, very long time ago. That's the beauty. It's not, they're still used here. You want to understand here. So there are different PDF format here, text format, HTML format. The original one is text format here. I was in the industry, so I just read the text format is good enough here. They are identical info. So we read the text format here. Text format you see here, internet protocol. DARPA, D-A-R-P-A, DARPA. That's government project. They call DARPA here. And that's 1981, about 40 years ago. Defense, U.S. Defense Advanced Research Project. That's DOD here. By Information Science, USC. So that's California, a good school. Professor created IP for the government. And you see here that it's very, very written in good English and easy to understand English here. They tell you what is motivation here, scope here, interference here, and what is the standard here. So operation here, the internet protocol treats each internet datagram as an independent entity, so something like that. It's very easy to read here. And see here, that's your format here. Now let's take a look. That's your TCP, UDP here. We don't have time to talk about UDP here. So let's say TCP. What's my IP? IP, right? Your address here, and this is your number here. Like 1 out of 3, 2 out of 3, 3 out of 3 transaction. You need to have a sending side, receiving side IP address here. Okay, and this one here, like local network protocol, like using a LAN, for instance here. Then it's Ethernet. So this is your Ethernet. We're talking about 802.3, and this is your IP protocol here, and this is your TCP protocol here. And you want to do telnet, remote login to the system. You want to do FTP, file transfer protocol. That's attached file. So they are showing some example more than that here. So keep continue here. They show you how it works here. That's your TCP IP in 791. So if we come back here, we'll going back here, 791 here, and we search here. Say 793. See, can we find something else here? 793 here is TCP. So 793, 791. One's TCP, one's IP. I remember, I use it all the time. That's your TCP. Same idea. Obsolete 761 here, update by 1, 2, 3, 4. And then you go to RFC 793, that's your TCP IP. The sequence number, you go to the text format here, 1980, same idea here. USC here, the school here, created here, same idea. So take a look here. So what's TCP? Yeah, higher layer here, like FTP, remember? File transfer, potential file here. That's your TCP here. The sequence number of your packet, 1 out of 2, 1 out of 3, 2 out of 3, 3 out of 3. IP address, sending side, receiving side, communication network, Ethernet. That's your LAN here. Scope here. So that's very, very easy to understand. Yep, you can read it here. So that's your standard. So what's TCP/IP? Many ways to learn. One way, I think you can Google Wikipedia. What's TCP/IP? That's good. That's a very good starting point here. But working in the industry, you cannot be based on Wikipedia to design or testing anything. That's not acceptable here. You still need to using TCP/IP under IETF. That's a standard here. Okay, so we'll come back here, simply book here, come back here. Yep, that's what we're talking about here. I'm going to stop here. So today we talk about TCP/IP protocol here. And before we talk about wireless Wi-Fi. So Wi-Fi, TCP/IP, both are very important. And we talk about media here. Twisted pair wire here, cable TV cable here, fiber here. We talk 3 important topics here. Oh, that's next time. Yeah, that's all I want to talk about this time here. I'll see you next time.